Assalamualaikum warahmatullahi wabarakatuh and hi. So today my group members and I will be present about our project for this DSA subject on the topic Calibre. Calibre is a e-book management application. As you can see here, number one, my name is Nabatisha Alia binti Muhammad Fazali and I will be the first presenter for our group. I will start this presentation by introducing you to Calibre. Calibre stands as a powerful and versatile open-source ebook management application designed to provide users with comprehensive tools for organizing, converting, and syncing their digital books collections. With an intuitive interface and a wide range of features, Calibre has become a go-to solution for ebook entities, offering a centralized hub for managing and customizing their vast libraries. Significant in ebook management. This section I will be introduce you to four main management in Calibre. First, we have organization and metadata management. Calibre excel in efficiently organizing ebook by allowing users to categorize, tag, and edit metadata. It employs data structure like linked list and array to streamline the storage and retrieval of essential information of each book. Second, we have format conversion. One of Calibre's key features is its ability to convert ebooks between various formats. Behind this functionality lies a sophisticated algorithm that leverages data structure to ensure seamless transition between different file types, providing users with flexibility in compatible devices. The third one, efficient searching and sorting. As the scalable ebook libraries grow, efficient search and sorting mechanisms become very crucial for the management. So, Calibre implements data structure like trees and hash tables to optimize search and retrieval operations, enabling the user to quickly locate and access their specific books within their own collection. And I'll proceed to number four. We have user customization. Calibre empower users to customize their reading experience by allowing them to create virtual libraries, manage cover art, and adjust metadata. The application architecture supported by appropriate data structures facilitate these customization features. Overview of Calibre's functionality. Although this section will be found repetitively, to next section, I think it's still necessary to explain for a newcomers that never used Calibre before. So here are 9 quick overview of Calibre's functionality. Number 1, we have library management. Import and organize. Calibre enables users to import ebooks from various sources and organize them in a centralized library. Metadata editing. User can edit metadata such as title, author, and cover art to enhance the organization of their ebook collection. Number 2, format conversion. Cross-format compatibility. Calibre support a wide range of ebook formats and provide powerful conversion tools to switch between them. This ensures compatibility with different e-readers and devices. Number 3, we have ebook syncing. Cloud integration. This enables users to syncing their ebook libraries with cloud service, allowing them to seamlessly access to their collection and across multiple devices. Number 4, ebook reading. Built-in viewer. Which mean by this, Calibri includes a built-in ebook viewer that supports various formats, providing a convenient way to read and preview ebooks within the application. Number 5, news and magazine. Fetch and convert. Which mean by this, Calibri will allow users to fetch news articles and magazines from the web and convert them into ebook format, providing a unified reading experience. Number 5, plug-in architecture. Extendable functionality, which mean by this, Calibre plug-in architecture allows users to extend its functionalities by adding custom features and tools according to their specific needs. Number 7, search and sorting. advanced searching, which means by this, users can perform advanced search based on metadata, tags, and custom criteria. This will enhance the ability to locate specific ebooks quickly. Sorting option. Calibre will offer various sorting options contributing to an organized and user-friendly library browsing experience. Number 8, content server. Remote access, which means by this, the built-in content server enables users to access their Calibre library remotely through a web browser, providing flexibility in accessing ebooks from different devices. Lastly, news server, automate fetching, which means by this, Calibre News Server automates the fetching of news articles from selected sources, converting them into an ebook format for easy reading. Next, I will be listing all application operations that involve in Calibre, and I will describe them briefly. Number 1, add book. It will operate to import and add new ebooks to Calibre library. Number 2, edit metadata. It will operate to modify or add metadata information for individuals ebooks such as title, author, text, and cover art. 3. We have convert format. Change the file format of ebook to ensure compatibility with different e-readers and devices. Number 4. We have ebook syncing. It will operate to synchronize the Calibre library across multiple devices, ensuring consistency in user collection. So number 5, we have ebook reading. It will operate to utilize Calibre's built-in viewer to read and preview ebooks directly within the application itself. Number 6, fetch news article. This will operate to retrieve news articles and blogs from the web, converting them into an ebook format to read. 7. Create collection. This will operate to organize ebook into custom collection or shelves based on user preferences. Number 8. Search and sorting. This will operate to perform advanced search and sorting operation based on metadata, text, or custom criteria. Number 9, we have content server. This will operate to enable the built-in content server to access the Calibre library remotely through a web browser. Number 10, news server. This will operate to fetch news articles automatically and convert them into an ebook format to easy reading for the user. Number 11, plug-in usage. This will operate to extend Calibre's functionality by adding or removing plugins to meet specific user requirements. Number 12, library backup and restore. This will operate to create backups of the Calibre library and restore them as needed for data preservation. Number 3, format-specific operation. This will operate to convert the PDF and handling specific ebook format and managing formats like MOBI or EPUB. Number 14, customization and preferences. This will operate to customize the appearance and behavior of Calibre according to the user preference. Number 15, we have batch operation. This operates to perform on multiple ebooks simultaneously, such as bulk metadata editing or format conversion. Number 16, tagging and labeling. This will operate to apply tags or labels to categorize ebooks, providing additional organizing options. Number 17, we have virtual library creation. This will operate to create virtual libraries or shelves to organize ebooks based on user-defined criteria. Number 18, libraries maintenance. Operation like repairing, checking, or optimizing the Calibre library for data integrity and performance. And thank you. That's all from me. I will pass to my team member.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Nizan Christina Binti Rozadi, and a very good day to our madams and Arya. So, in our project, I was tasked from my groupmate to do demonstration of the use of the data structure operation in the app Calibre. So, the data organization and the storage pattern are crucial for efficient management of ebooks. And the selection of specific data structure is influenced by the nature of data, to be stored and the operation performed on it. So there are several descriptions of the data organization and the storage method, along with its corresponding data structure. Okay, next, I will be explaining the several functions in the Calibre. So my friend has previously explained to you that there are 10 options on how to operate this application, and some of them use the same data structure, but it still vary in its function. In this explanation, some tutorial of how to use the apps, which mean this app's Calibre, and some edit diagram will be shown in the section. Okay, in this slide, I've shown you a screenshot of the app's Calibre, and we could see there's a lot of function here, and I could navigate you through by one and each one of them. So we could see from here, there's a function add books, they also edit metadata, convert books, view the books, get books. You could also add your favorites here. And there's also fetch new if you're into reading news. They also have help button here. And if you don't like any books or you want to save storage, you could remove the books. And to view your library, you could see the function here, Calibre Library. And you could also save it to this. Well, there's more. You could see here there's also connect and share. You could also edit your book and the song preferences. There's a lot of editing here, and there's a you could see here there it shows the front page of my books here. I just added here digital principle. There's a few examples I could show you later on the slide. Now I will explain on how to use one of the function here. The very first function I told you before, which is add book. You can see here from the given screenshot. Okay, I already added digital principle books here. And then also the first book that they give to me when I first download this app, which is Quick Start Guide, or I would say guide to use the Calibre. So, in this very front page, how to use add book, how does the function works in terms of its data structure? So I will explain how it use hash table. Interestingly, use hash table when a new book is added. Its metadata, it could be like title, the author, in even the ID itself, it's collected. You could see here, the author is unknown because I uploaded it on my own. It also put on the dates, the size, and when it was published. Okay, in this case, digital principal ebook, the author is unknown, I already told you, and the ID is 1. I will further explain about the hash table for the add book function. So the book's ID, in this case is 1, is hashed using a hash function to determine its index in the hash table. So we only give the index code for the books given, which is 1. So we could see here from the diagram, digital principal ebook is also being hashed here. There's a hash function here. So we move on to the hash table. The pink table is the hash table. So we move on from the index and it will edit the value. So the index is 0, 1, and the value will be value 1. Same goes to the guide for Calibre. It will go to hash function and it will give the index number, which is 2. The value will be value 2. Same goes to BBC News. It will go to hash function. It will give the index value, which is 3, and the value will be 3. Okay, moving on to the next function, which is edit metadata. So here's a screenshot of the app's Calibre. You could see there's a lot of function that you could edit your books if you making your own book. So there's a lot of function here. You could see you could change the title, you could change the author. There's also series if you have a lot of books coming out. You could also have the title sort, the author sort, you could also change the format. This one is in PDF. You like in other format. You could also do that as well. And interestingly, you could also change the cover for this. If you like some artsy stuff, you could also do it. So this is the screenshot of the Calibre. But what I will explain what is going on behind it, which is the data structure of this um function. So it mainly uses linked list, which is each ebook is represented as a node in a linked list. And a search is performed to find a node corresponding to that book. That's how you will do it. So the explanation regarding the linked list here, the linked list is traversed until the node corresponding to the desired book is found. The metadata of the found node then is then modified according to the user's input. So for example, the user can edit the author's name and it will be stored as modified node in the system. So I'll further explain on how this system works. So I've shown you there's three different nodes here. So this node are represented by the three ebooks I've shown you. So there's a digital principle ebook, Guide to Calibre, and BBC's new. So the linked list is traversed between these three nodes. I have shown you there's only three examples here, so it travels between these nodes. So in order for you to find this book, for example, if you want to edit the Guide to Calibre, it will find this node specific node first. That's why the linked list will traverse until the node correspond to the desired book. The desired book in this case is Guide to Calibre. So in this Guide to Calibre, you want to edit it in the metadata. In this case, you want to change the title. Will it be the Quick Start Guide, for example? You change it. You change the title. You change the title of Guide to Calibre to Quick Start Guide. So the changes that you make will be a modified node in the system. Moving on to the next one, which is convert format. Convert format is the third function in the Calibre. So you could see here there's a function of convert books here in the icon of the chocolate color and the conversion sign. So you could convert the book. In this case, you could convert it from PDF to EPUB, EPUB to PDF. So the main data structure that used for conversion here is stack. Okay? So you could see here a new job that represents the conversion task is pushed onto the stack. In this case, conversion of digital principal book is being pushed while the guide is being popped. How could I explain this one is, based on the screenshot I've shown you here, there's a jobs here, jobs one. And actually, the running time here is very fast. So it's actually jobs two. There's two jobs. Since we are also converting the guide to Calibre and digital principal. There's two jobs, honestly. And since the guide to Calibre already been converted, so there's only one job left for the Calibre to convert the digital principal. Okay, for further explanation regarding stack here, the stack is popped to retrieve the next conversion job to be processed. Okay, the format conversion operation is performed and we will obtain the result here. Okay, so in some cases, if you want to convert the book here, if the book's already been converted, let's say you already convert it from PDF to EPUB, so you want to convert it by EPUB to format, EPUB to PDF, it can also convert it back to its original form without it disturbing the process. The job is still the same. It's still count as jobs. Even though all the books are not being converted yet, it's still the same. It's still called a stack. Okay, so I will explain the diagram here, how the jobs work here. Okay, so it begins with the empty stack. The top is 0 or less than 1 in this case. So we push one job here. We'll push one job here, which is we want to convert the digital principal ebook. So we will push the digital principal ebook into this empty stack. So the top will be 0. Stack is equal to 0. Stack is 0, but it's equal to 1 because we have one job here. Next, we will add a new job, which is the conversion of guide to Calibre. So in the stack right now, you have 2. Stack is 1, but it's equal to 2. But the top is equal to 1. The top one is the guide to Calibre. Okay, the next one, we will pop the guide to Calibre because we want to do the conversion for the guide to Calibre. Since it's on the uppermost part of the stack, it will be popped first. Okay, so in this case, the top will left with 1 and the return step value will be 1. So that's why in the previous slide, the job left with 1 because guide to caliber already being converted, but digital principal input haven't been converted yet. Okay, moving on to the next function here, which is the ebook reading. The ebook reading here, as you can see in the screenshot I showed you in the slide, um, apparently when you upload the any ebooks that you have or any PDF form, this is how it being translated into the caliber. Um, there's some missing um pictures a bit, and the format's a bit different. Even the font's a bit different, and it's not accurately because you read it through an app, right? So this is the format it looks. Left with the text here. Okay, that's on the Calibre app. So it in the ebook reading. So what kind of letter structure we're using here? You also use linked list. Okay, so when user opens an ebook, the linked list is populated with the content of the ebook, divided into pages or chapters. Since there's a lot of content inside this ebook, um, so many things, so you need to sort it out in this way. So we need to use linked list to navigate through all the contents of the ebooks. Okay, so for the explanation here, I already explained it that the user progresses through the ebook by navigating through the link list, moving from one page or chapter to the next. So in this case, for the example and the diagram I showed, we will use pages here. And the linked list allow for efficient navigation between pages, and each node represent a distinct part of the ebook. So here's the linked list I've shown you in the diagram here. So there's a few pages. So from the page 1, we could say it looked like this. And moving on to the page 2 and the page 3. And all of these pages represent as notes. So it's very important to note that all of them are notes, and it could be also applied to the chapter as well. All of the chapters, known as chapter 1, 2, and 3, all of them will be categorized as one notes. And we could also navigate through them one by one. So this is the portal of linked list so that the user could easily move between the pages and through the chapters. Okay, the next function here is the fetch new articles. So how do you want to read the new articles? So we have the function here. You can see here from the Calibers app, there's a lot of options ranging from the language, the country where it's from, and even the country it's from. We also have a lot of options from different publisher here. So for the example I use here, we use um, English from the United Kingdom. As you can see here, even in the slide I've given to you, um, you could schedule when you want to get the news. Like you want to set it every days of the week, or you want to get it one day time of the week. It's very convenient to use, and for me, it's very exciting features that I could see in Calibre, and I could say it's very beneficial in this one. So furthermore, I would say what type of data structure we're using here. So we're using Q here. All of these news are URLs. Is from the other site, so we just pasted the URLs here. So the URLs of the article to be fetched are in queue, and the queue is the queue to retrieve the next article URL to be processed. So the Calibers here fetches the article content based on the URL that you selected. Okay, for the explanation here, I already told you that there are so many languages and publisher that you could choose from. So I showed you in the slide here, I chose English from Canada. Even though Canada itself has 29 publisher that you could choose from. But in this case, I use English from United Kingdom. And you could see on the left here, I chose news, which is BBC News on the date of Sunday, 31st December 2023. You can see here, this is how it looks inside the caliber. The news itself inside the caliber. It's also have a very nice pictures here. It's almost the format of you could expect from the online. Online is new, you could read, whether it be from Star or something. But in this caliber, it looked like an ebook. So you could flip between the pages, or you could say you click between the pages here. It's very convenient. Okay, before I'm moving on to the explanation about the queue, I want to address that the fetch new articles and the news server are the same thing. It used the same data structure, which is queue. So the explanation that I do here will be the same as in the news server. Okay, moving on into this explanation. The diagram below shows the process of queue for selected new categories here, which is we chose English for United Kingdom based on URL chosen. So queue operate on two things, which is Leo and FIFO. Last in, last out, first in, first out. So I would say that in this case, it's last in, last out. Okay. This is the simplified diagram on how to explain how the news are being fetched. Okay, start from the in queue here. In queue here from the Birmingham Post, and then in queue the Birmingham Evening Mail, BBC Sport, BBC News Fast, and BBC News. So you get queue here from that, from the rear. Okay, from the rear one. So since the URL chosen here is BBC News, it's being dequeued. It's being dequeued. So we took this one and we received since we click on the URL, so we have this one as the news that we want. So that's why it's being dequeued here. And they still have a lot of one, but this is the sample size I shown you, which is only 5 news here. Moving on to our next function here in the Calibre, which is create collection. So you could create collection in the Calibre library here. You could see in the screenshot I shown you in my slide here. You could choose any of the book you want and create a collection based on that. You could say that you want to make a collection for um your fictional books, or you could say this is your for study book or for your reference book. You could create all the collection and you could group it into one. So this one is an interesting case because in order to perform this function, we use two data structure here, which is tree and hash double. So when a new collection is created, a new node is added to the tree to represent the collection. And the collection is also added to the hash table. So it go in between this one, uh, relying on each other because it store the data of what we created in this Calibre app. Okay, so for the explanation for the create new collection, ebooks that belonging to the collection are linked to the collection node in the tree. And the metadata is updated in the hash table. As you can see here, there are a few nodes I've shown you. Root as being the one here. So when you create a new collection here, a new created collection here will call as two. Okay, you could say it'll be like a reference book. In this case, it's a reference book. So it's a collection two. Two is the collection one. So if you want to add a new book here, 4 and 5, I refer to the new book edition, it will be added in this way. It's the concept is still the same. It's a parent-child concept. So it will be added under the two collection. The 5 one, it could be example like the digital principal book will be connected to the collection of the reference book. And this is how it works for the new create collection. And here I would say when you already update when you already edit the collection, the new created collection is given index 2 here. I give it as an index 2 and has been added to the tree. Okay, index 2 is the hash code for the new collection in the hash table. So you could see here in the hash table, the new collection, which is 2, is go to the hash function, and the index will be 2, and the value will be 2. In this case, you could name it 2 the PDF book. It's a new collection for you, and it will go like this, and the index will be 2. And that's all for this tree and hash table for this create new collection. Okay, moving on to the next function here, which is search and sorting. Okay, in this slide, I shown you the screenshot here. We have the function here, sort. We could sort it. And we could also sort it in any way that you want, which is by the name, number of book, or average rating in the Calibre apps. So interestingly, it uses a lot of data structure here. It's the most in compared to the other function here. It use three data structure here, which is tree, hash table, and sorting algorithm. For the explanation of the um, search and sorting, okay, so for different items here, I could say there are different things that you could do. So for the title, the hash table is consulted for quick access to the book metadata. And for the genre, the tree travels to find all books under the corresponding genre node. And we will be focusing on the sorting algorithm here. So the sort books by author in this case, a sorting algorithm, which is selection sort, is applied to the author metadata in the hash table. So the sorting algorithm after it's being sort, so it can quickly being accessed through the hash table and go to hash function, and it goes from the hash table here for the user access the author's books. On to the explanation for the sorting algorithm here. Since we use selection sort, so this will be the explanation of it. So I give you the six sample sites here. Okay, selection sort use the method that you need to compare the value here. Okay, let's say the author's name were in index here. Okay, so how do we begin here? So 5, 1, 3, 4, 6, and 2. So in this case, we need to look which one is the largest and the smallest one. So we observe it from 5, 1, 3, 4, 6, 2. So you compare and contrast between all of this. You can say the sixth one is the largest. So it goes behind, goes at the back, goes at the back here. Okay, goes at the back. And now six, we don't disturb six because it's at the back because it is the largest. Now we will see here from here, 5 and 2. 5 and 2. Which one is the largest? It's going to be 5. So we move the 5 here. It's only two, we only change between the two index here. Okay, that's how it works. And then after we're done with that, 5 and 6 will be left undisturbed here. It will be left here. Okay, now we will see it starting from this one and this number. So we compare 2 and 4. Since 2 and 4, 4 is larger than 2, so it remain here. So it will be remain here as being undisturbed. Okay, and then we're moving on to 2 and 3. So 2 and 3, obviously the largest one will be 3 here. And then moving on 2 and 1. Of course, 2 is larger, so 2 will move on to this one. Okay, and that's how the selection sort works and this Calibre app in order to find the authors. Okay, moving on to the last one here today, which is the content server function. Okay, content server function you could see here is still the same. It's basically all about the Calibre app itself. So it also use two data structure here, which is tree and hash table. Like say the browsing books or accessing metadata, the server utilize both the hash table and the tree. Okay, for the explanation here, for a specific book, the hash table provide a quick access to its metadata, including the title, the authors, the genre, or could be many more, as I refer to what Calibre apps offer here. And the tree structure here is used to organize book hierarchically. It's facilitating navigation based on the titles, authors, genre, and could be many more things that could be listed by Calibre app as well. So I already show you a diagram here, a very simple one, since I already explained the previous one. This is a tree structure. So that says for title here, it could go from this one title, like it could be the same one. This title, let's say, it's gonna be, a reference book, right? A reference book. And it goes down there. It could be a reference book for biology, or you could say a reference book for physics, or reference book for any subject that you say. And same goes to the author as well. The author itself have a lot of publishers and goes for genre. So um so let's say this is one is for the uh, tree structure. How about the hash table? The hash table itself I already explained from the previous slide. It provides a quick access. A quick access as in we quickly access the value from its index. So we already have the index of the specific book. Let's say the specific book that we chose today is Digital Principle, which is index 1. So we choose that one, we could easily retrieve it from the metadata. So this is very important in the system. If we have more books, we really need the trick structure in order to organize to facilitate the navigation between all the authors, the title, so that it's easier to connect to this Calibre app. So that's all for me. I hope that my explanation is clear, and I'm very thankful to this given opportunity to explain this part to you. Thank you very much. And I'm Miza Christina binti Rozaidi. Assalamualaikum warahmatullahi wabarakatuh.
Hi, my name is Nodawisha Farzana binti Zulhaidi. I'm member number 3. I would like to continue to present task 3, which is algorithm for one operation. So we choose adding a book to Calibri library. In this task, we delve into the detail of add script section, focusing on the add book script and how array and list may be involved. First, initialize an array for book title. An empty array named book title is initialized to store the title of the book being added. Second, loop through books. The script iterates through each book file in the specified directory. Third is extract metadata. The ebook meta command extract metadata from each book file. Time complexity is 0 bracket 1 per book. The extraction operation is constant time per book, assuming the metadata extraction time is relatively consistent. 4 is add to array. The book title is extracted from the metadata and added to the book title array using the plus equals syntax. Time complexity is 0 bracket 1 per book. Adding an element to an array is typically a constant time operation. Fifth is add to Calibre library. The extracted metadata is used to construct a destination path within the Calibre library. The ebook convert command is then employed to add the book to the Calibre library by converting it to the Calibre format. Time complexity is 0 bracket 1 per book, assuming that the conversation time is relatively consistent. The time complexity is constant per book. 6 is logging. The script logs the added book title to the console. Logging the added book's title is a constant time operation. Lastly, display all added book title. After the loop complete, the script display all added book titles stored in the book title array. Next, this is a list of data structures involvement. First is array, second dynamic array modification, third is array display. By utilizing array, the script maintains a dynamic list of book titles, providing a structured way to store and manage this information. This approach can be especially used for future processing or logging purpose within the script. Overall efficiency. The overall efficiency is dominated by the loop through the book file, making the time complexity of the entire script O bracket n, where n is the number of book file in the specific directory. Factor to consider. The actual efficiency depends on the performance characteristic of external command like ebook meta and ebook convert. If this command exhibit variation in execution time, it could impact the overall efficiency. Conclusion. The algorithm demonstrates a linear time complexity, making it suitable for moderate number of book file. If the number of book file is expected to be large, further optimization may be considered, such as parallel processing or optimizing the performance of external commands. So that's all from me.
Hi and Assalamualaikum. My name is Nur Fatia Shafika binti Muhammad Rasli, and I'm going to continue present questions number 4, which is to present the existing applications code with the output and identify the collection class and the interfaces used, and also list all the operations from the class and interface for each. In this example, array list is used as the collection class and the list interface is implemented. The operations include adding a book and removing a book. Let's explore the operations in the Calibre's library class, a central component of Calibre's functionality. Add book to add a new book to the library. Remove book to remove a book from the library. And the last one is get all books, which is to return a list of all books in the library. Now, let's take a closer look at the operations in the book class, which serves as an interface-like structure for representing digital books. The first one is the constructors, to initialize a new book with title and author, and the last one, getters and setters, to retrieve and modify book details. And the last one, I will present about the conclusion and summary of the data structures in the apps Calibre. Number one is the data structures in Calibre. Calibre employs a variety of data structures, including linked lists, hash tables, trees, queues, and potentially more, to efficiently manage its extensive features. Number two, application operations. Operations such as adding books, editing metadata, converting formats, syncing, and reading are crucial to Calibre's functionality. Number three, data organization. The data organization in Calibre is influenced by the choice of specific data structures for tasks like metadata storage, format conversion, and library organization. Number 4 is efficiency and running time. The algorithm for adding a book has the time complexity of O(n), where n is the number of nodes in the linked list. It is efficient for small to moderately sized libraries, but the linear traversal may impact performance for very large libraries. The next one, role of data structures. Data structures play a pivotal role in optimizing Calibre's operations. Linked lists efficiently handle metadata updates, queues, and stacks and aid in format conversions. Trees organize collections, and hash tables enable quick access to metadata. Number 6. Efficiency findings. Calibre's efficiency is evident in its use of appropriate data structures for specific tasks. The linear traversal of the linked list during book insertion is a consideration of scalability. Number 7. Improvements and optimizations. Recommendations for improvements include using self-balancing binary search trees, optimizing hash tables, implementing caching, considering parallel processing, and exploring database integration. And the last one is a conclusion. Calibre's architecture showcases a thoughtful selection of data structures to balance efficiency and functionality. Ongoing optimizations and improvements can further enhance the application's scalability and performance. The role of data structures. Calibre's efficiency is intricately tied to the strategic use of data structure. The selection of linked lists, trees, hash tables, and other aligns with specific tasks, optimizing operations such as metadata management, format conversion, and library organization. While the algorithmic complexity of certain operations may pose considerations for very large libraries, the overall role of data structures in Calibre is crucial for delivering a feature-rich and user-friendly ebook management experience. Thank you.